We're given a right triangle, and all three side lengths are defined using one variable, lowercase a. The bottom base is a. The vertical leg is 2a, and the hypotenuse is 3a. Our goal is to find the value of a. Let's start with the Pythagorean theorem. For a right triangle, base squared plus height squared equals hypotenuse squared. So we have a squared plus the quantity 2a squared equals the quantity 3a squared. Now simplify. 2a squared is 4a squared, and 3a squared is 9a squared. So a squared plus 4a squared equals 9a squared. Combine the terms on the left, and we get 5a squared equals 9a squared. Subtract 5a squared from both sides, and we get 4a squared equals 0. Therefore, a squared equals 0. And so, a equals 0. But wait, what does that actually mean? If a equals 0, then the base is 0, the height is 0, and even the hypotenuse is 0. So we don't have a triangle at all. Everything has collapsed into a single point. And here's where the puzzle gets interesting. What if we assume that a is positive? Could we simply divide both sides of 5a squared equals 9a squared by a squared? If a is positive, then yes. But doing that gives us 5 equals 9, and that's impossible. So something must be wrong with our original assumption. The problem is not the Pythagorean theorem. The problem is that these three lengths cannot form a non-zero triangle in the first place. Let's see why using a fundamental rule of geometry, the triangle inequality theorem. It says that the sum of any two sides of a triangle must be strictly greater than the third side. Look at our two shorter sides. They are a and 2a. Add them together, and we get 3a. But the third side, our hypotenuse, is also 3a. So the sum of the two shorter sides is exactly equal to the third side, not greater. And that is impossible for a genuine triangle. Geometrically, if you tried to construct these three lengths, the two shorter sides would simply lie along the same straight line. There would be no enclosed area, no actual triangle. The only value that satisfies the equations is a equals 0. But that doesn't give us a triangle. It gives us a completely collapsed figure. A simple-looking triangle with one tiny condition, and suddenly the entire figure disappears.